hopefully make a little bit of a start. So I have been teaching this for about 6 years really, a little bit longer than that since I started teaching. I'm not going to say that I'm a complete expert at all, but I have got a few hints and tips that hopefully you will find useful as we go through. And I can just go through and show you a few of my bits and pieces. So the aim of this really is just to have a little bit of free CPD that we'll go through some of the hints and tips. I have been marking the OCR Component 2 for a few years, so I'll use some of those tips that I've learned from doing that, and I've been a team leader there as well for the last 2 years as well, so you get a little bit more of a feel for what's kind of needed. I will stress that this is not an OCR course, but it's just me offering to help out a few people that said that they might want a little bit of extra guidance and through the component too. And hopefully if you are able to talk, there's a chance for you to share some of your ideas if you've got anything that will work or that you think works really well. And hopefully just do this for about an hour each week, and if you can make it every week then you're more than welcome to. I'll obviously try and record them, so if you do miss any of them then you can do those and catch up with those at a later point. And I'm always at the end of the phone if you like, and if you want to get in touch with me about anything else then I'm more than happy to help. Obviously it's a nice little chance to catch up and really plan things properly, which I think we don't necessarily get a chance to do when we are teaching non-stop. So it could be a little bit of a blessing in disguise, but we'll see. I'm not too sure what your students have been like, but mine have been pretty good. Not necessarily needing too much help from me as well, which is even more of a bonus. So today I just thought we'd start and just have a look at kind of the 2.1 section. Won't get through too much, I don't think. It's a little bit of an intro one, and hopefully sorting out a few teething issues that we've already had so far. But this is kind of everything for 2.1. Hopefully you're fairly familiar with the specification for it. The kind of 5 main areas they need to have a look at are the computational thinking, standard sorting and searching algorithms, and then obviously creating algorithms in pseudocode and flowcharts, and also obviously being able to interpret and correct any of the algorithms that they might be given. So we're going to just have a look at the computational thinking element. This is the bit that I feel is the most important part. It's kind of the fundamentals that will then help them to hopefully start to grasp everything else. I spend maybe 3-4 weeks just looking at these computational thinking methods at the very beginning of the course. At the moment we start in year 9, which is quite nice because we get year 9 which is just learning to program, which helps to build up all their skills and things, and it gives me a little bit of extra time compared to some schools, I think, in terms of lesson timing and getting them prepared for their exams. And it's just a little bit of a fun year where we don't have to have those pressures of exams and things like that. They're just really learning to code and think computationally, really. So when it comes to the different methods, so abstraction as a definition is looking at removing detail from a problem in order to make it easier to solve. One of the key elements with this one, the key kind of misconceptions, I suppose, that students tend to have is they tend to talk about the program rather than the problem when they're saying about removing unnecessary detail, and they really need to make sure that they are emphasizing that it's the problem that they're removing the unnecessary detail from and not the solution. I think it was last year that there was this question in there about defining it, and a lot of students lost marks because of it. And one of the other things is that sometimes the way that they word this answer can also kind of harm their chance with the exam element. Some weren't able to get the marks because it said things like taking out the important information, which, although we could probably assume that they were talking about like making sure they're picking out the important bits, it's not clear enough that that's what they mean, and that they don't actually mean they're removing the important information and that sort of thing. So I think the way they word these definitions is definitely really important for them to make sure they do get the marks and show that they do understand what's being asked of them. And so at the start of the course, I tend to spend maybe 1 or 2 lessons doing a little bit of work just on abstraction and trying to tie in maybe where they might use it in more general terms. And I think one of the key bits is exam questions, and a lot of the time they'll be using abstraction whenever they're trying to answer exam questions. What's the important information in a particular question? And it's really kind of useful to try and tie in those kind of extra examples that won't necessarily link to computing, because I think that helps them to understand and visualize what's going on. One of the things that I find quite useful for it is this activity from Barefoot. I don't know how many of you know about or have used Barefoot, but it's a really good organisation for primary teaching. But there's some really quite fun activities that you can use, and I've used this kind of activity right up to A level as well. And it's basically like Pictionary, and you're getting students to either draw or describe an element or some kind of object and get them in pairs to have a guess. And obviously that there's that element of, right, what do they need to make sure they're including in their description or their drawing to make sure they get the right answer. And it's that kind of little bit of fun that you can add to the course. And I think one of the key bits is there's lots of different resources out there, and even if it does seem like it might be a little bit young for some of the kids, I think it's nice to have that little bit of fun, that they can have something that's not too difficult for them to do, and something that they can kind of come back to and hopefully just enjoy for a little bit, because I think too much of it is exam based and exam focused a lot of the time. And obviously there's lots of other things. When it comes to it, we look at using highlighters and things like that to try and just highlight what the important parts are when we're then going on to more algorithm based problems. Get them just to get a highlight. We use OneNote a lot, so I just get them to use the highlight tool on there and highlight the important parts within that particular problem. But then I'll also get them to just get in the habit of bullet pointing those bits they've highlighted, just to make it really clear that these are the bits that they've identified as being important, so it's clear that they've highlighted the correct parts and so on. And as I said, I'd spend kind of a couple of lessons just doing a little bit of work on abstraction as I go through. If you are able to talk and you have got any questions at any point, please feel free to just let me know, and I can go through and I'll hopefully answer any questions that you might have on that. But hopefully that's fairly straightforward and is something that people are familiar with. Then you've got decomposition, and decomposition is obviously looking at breaking down the problem into smaller parts. I think generally students find this easier to describe what it is, but they don't necessarily find it as easy to apply. I think they find abstraction quite easy because they're used to doing it and picking out important parts of a question and things that they might do in maths and that sort of thing. But when it comes to decomposing it, I think they do sometimes struggle to work out where they can break it down into different parts. Especially if it's a really small problem. We tend to look at doing breaking it down into kind of inputs, processes, outputs initially when they're just doing really small problems. And then as the problems get a little bit bigger, then they can start to think about, right, okay, well, for each of those smaller problems that they've managed to identify, how can you then apply the inputs, process and outputs on there as well, just so they kind of get into the habit of really trying to break it down as far as they possibly can. Again, you probably spend about two weeks or so on doing this. We'll have some activities where they first have to then apply the abstraction to it, and then they can have a go at decomposing it into the different smaller parts that they hopefully find a lot easier to solve, and looking at just trying to plan really. I think the key bits with these two sections is it helps them to plan and will help them with their coding later on. So it's not just about doing the coding side of things, it's and understanding it for the exam. This is going to help them with breaking their own problems down and creating their own algorithms later on. Then you've got your algorithmic thinking, which is looking at creating a set of logical steps to make a solution to the problem, or just writing a set of instructions for a problem. And I think if the abstraction and decomposition elements have been applied well by the students, this next step should be quite easy. There's kind of three main ways that OCR look at doing this, and that's looking at flowcharts, pseudocode, and at the moment programming languages. Obviously that is changing for the new spec of the J277 to be OCR reference languages, as well as an alternative to a high-level programming language. But I add in an extra step before that, where we look at just writing just some kind of structured English. And when we're doing our initial bits on computational thinking for the first kind of 2-3 weeks of the year 9 year, when we're introducing this, we don't worry about anything like flowcharts or pseudocode or programming languages. I just get them to have a go at writing instructions as a series of steps. So this is an example of a problem that I gave them at the start of the year. So they have a little bit of a problem statement, and then I get them to identify those key elements using abstraction. Then they can move on to decomposing this. So this is quite a simple one. So I was just looking for inputs, processes, outputs for it. And then for the algorithmic thinking, they can then add that into there, just writing down in English what they think the first instruction might be, then the second one, and trying to break that down as much as possible. And I think I gave them about 7 or 8 of these different tasks over the course of a few lessons, just to get them into thinking about how they can break that problem down and write it in as clear an instruction as they possibly can. I think it is really important to look at doing this and trying to think, where possible, of real world situations as well. So things like being able to make toast or cups of tea, or whatever you might do. Walking to school, we've done in the past, and all those things where they can have those kind of links to real world, so they can think step by step, and hopefully break it down as much as they possibly can. Because I think without focusing on these areas initially, I think you do find yourself with a little bit of a losing battle with some of the lower ability students, especially. And I think it's well worth spending that little bit of extra time at the start of the year, as much as you possibly can, to do these kinds of tasks, whether it is that you use them for homework tasks or things like that, because you don't have that much time with them. They might not come back to you or come to you at the start of your GCSE where they've had this background beforehand. And we are quite lucky because we do quite a lot of programming in year 7 and 8, and then obviously, like I said, we start in year 9 for our GCSE at the moment, although it is changing for us. We're going to the 2-year GCSE again, and so it will be a little bit more of a challenge, I think, to squeeze everything in, and we won't be able to do a full year of programming, but I'm hoping to still be able to do about 2 terms just programming the whole time, and keep a lot of it in there, and hopefully that will be okay still. But I think, like I said, these different ways of being able to go through and show them how abstraction and decomposition and so on work is really important. And then obviously once you've then got to that point, you can then start to bring in these other ways of writing algorithms, such as using flowcharts or pseudocode or programming. I tend not to go straight and go into the pseudocode. I'll tend to leave that one until we start to get to writing algorithms for exams, because I think it's a little bit more beneficial for them to be able to see how algorithms do work once they start writing them for the computers. And then once we get past that stage, then I'll kind of talk about pseudocode and those sorts of things. And obviously for the current year 9s that I've got, we'll be starting to talk about the OCR reference language and that sort of thing, and how they compare to what they've been doing with Python over the last year or so. When it comes to flowcharts, I think also it's quite good to be able to see how they work. And I don't know how many of you have heard of it, but there's quite a good app called Flowgriffin. Just find where that is. So hopefully you can see this. I don't know how many of you have seen it before, but it allows you to build up an algorithm. And although the shapes aren't all OCR spec shapes, so the loops and so on, they've got their own shapes in there. It does help them to understand how programs are built, and you can build it, so you do have to declare it a variable first, but what you can then do is build up all the different shapes as you go through. And then once you've got an algorithm, you can run it, and so the students can type something in and see what happens. See, it doesn't really do anything on that one, but see if they then built an output on there as well. Hopefully you'll be able to see that, so it goes through and they can see the program running. If they make a mistake, just like with a programming language, so if I get rid of the variable in there and or the variable name, I try and run it, you get error messages, and so you can start to teach kind of problem solving and debugging and testing and so on through flowcharts. And so that can kind of be a little bit of a middle step between going from the algorithmic thinking and so on, and in structured English, like I said I'd get them to do, and then moving on to doing some programming and something that's a little bit more difficult. And we actually use this in year 7 as well, instead of using something like Scratch, just because I find it a lot easier to then move on away from a kind of drag and drop language, because I do find that a lot of the time with Scratch, it is really good for some things, but a lot of the kids just like to sit there and play around with the characters and just do a lot of backgrounds and things like that, rather than focusing on the code. Whereas this is kind of got that drag and drop element of it, and it runs and they can see and they can start to break down the problem, but they can't sit there and just mess around for hours with making characters or messing around with the sounds and whatever it is else they find on there as well. So I find that really useful to go through and do. And then obviously from there we can then move on to starting to do some work on Flowgriffin and also on Python, and they can start to learn how to code properly on there. And so obviously for that one, we tend to use something called Thonny. I don't know how many of you have used that one, but it's just a Python editor that's a little bit more user friendly than the standard idle. If I just go shift to that one, I think it's a standard on the Raspberry Pi, which is where I found it when I did a little bit of a Raspberry Pi course. But it builds everything all into one place. And so that they don't have to worry about two windows and accidentally writing code in the wrong place. Because I was finding with the idle, a lot of them would try and write it in the shell and then wonder why they can't then go back and edit their code and those sorts of things. And the debugging tools are a little bit easier to find. You don't have to go through and tick the box in the shell and then run the program and faff around in that way. There's just a little bug icon and then they can step through it up there, and so it just makes it a little bit more user friendly for the students, I think. We have had a couple of issues with it, though, unfortunately. Some of our computers have to have it reinstalled every so often because they get a random error that can't be solved without just reinstalling the program, unfortunately. But it is quite useful to be able to use. And then as we go through, we then obviously look at trying to make sure we're embedding the skills as much as we possibly can. And we use a method for teaching programming called PRIM. I don't know if that's anything anyone's heard of before, but it's just a way of making sure that they understand what they're doing. I'm just trying to find. There it is. So this is our OneNote page for it, and I'll just find my first introduction lesson for Python. And so PRIM is this structured way of learning to program where they start with a little bit of code that they predict what they think they're going to do, and they can look at trying to work out what this obviously very simple bit of code is going to do based on what I've taught them up until this point. So I'll do a little bit of an introduction for the lesson, and then they'll go through and have a go at doing a few tasks on it. And so they have a go at predicting, then they can run the program. And my preferred method of doing it is making them type out the code just so they're getting used to writing the syntax. If you do any research into PRIM, some methods just look at giving them the code initially, but I think especially when they're needing to type code, I think getting them to practice typing the code as they go through only can help them out, because they start to see what the syntax is, and they start to learn some of the common errors that they go through as they go through that. Once they run it, they're then expected to investigate what's going on, and it's good to have a number of questions where they can have a look at kind of trying to answer whatever it is that you're trying to teach them. So thinking about what the purpose of something is, or just getting them to notice things. So I like to, especially at the beginning, get them to think about what they notice about the colours of things. So they're starting to think about the fact that the text editor is changing the colours for them so that they can differentiate between strings and functions and variables and things like that. And so just trying to get them to make those kind of links between things so that they can then see, well, okay, that's all green, so what have I not done, and what is the error that this is causing. And so that investigate bit is probably one of the most important parts of the ways of learning. And then you've got modify and make, which is where they're then starting to move on to writing their own code. So modify generally is just a very kind of small change to the code that they've already done. In the early stages, it's very similar, and they should find it quite easy to make those changes. But obviously, as you start to introduce some more complex programs and they're starting to do a little bit more, then those modify bits can be whatever you want, and they can have a lot more steps to them, and you can start to challenge them as they go through. And then the make side of things is where they're making a whole new program for something. Again, at the beginning, the make is very similar to the modify, I suppose. But once they start to do a little bit more code, and they start to use more techniques and build bigger programs, the make side of things is really a chance to start to challenge them and push them as they go through. I find that doing this is a really easy way to kind of differentiate and make sure that they're learning at their kind of own pace, and that they're getting the right knowledge and understanding at the beginning. So what I will tend to do is have 4 or 5 activities. So this one's just got 3 that will last maybe 2 lessons for some of them. Some of them will be done in 1 lesson. And then at that point, I can start to introduce other techniques. So we went on to looking at doing a little bit of looking at inputs and variables and so on. And some of the students were then starting to kind of whiz through these and move on because they started to get the hang of it. But the other students that hadn't quite got there were still back working on this introduction page, just because I feel I don't want them to be moving on too much. So you have this kind of staggered lesson, if you like, where you've got students at different stages, but kind of learning as they go through. And then kind of other ways to help some of the students out is just to give them a few hints and things. So for those low ability ones, so I have 3 different versions of each lesson. And so for the low ability ones, you might notice that I've got rid of the make side at the moment. So they've just spent some time doing some predicting, some running, some investigating, and some simple modifying tasks. But then at the very end, they go through and then create the make tasks as well. So they still do those make tasks, but they just do that in a slightly different place so that they are not getting too bogged down with, I can't do this make task, so I'm not going to move on. I think some of the lower ability ones I tend to find, if you can give them a number of different investigate and modify tasks, they then find all of the make tasks a little bit easier to do later on. And obviously the comments can go in there to help them out. And obviously the high ability ones that are whizzing through and they don't get any comments at all. So I don't know what languages that you guys do use. I do prefer using Python. I think it's quite a nice one to learn because the syntax isn't too heavy, and it also forces them to use things like indents and so on as they're going through. But that's kind of how we tend to go about doing things and showing how they can go through and start to learn about programming and those computational kind of thinking methods. When it comes to the make task especially, it's always worth them having a think about the abstraction and the decomposition and getting them to plan it. If they're really struggling with that element, get them to go back to those computational thinking methods and think about, right, how do I break this down into an easier to solve problem, looking at abstraction. And I think the key bit is with those computational thinking methods is to just keep revisiting them and make sure that the students understand that they're not just some terms, that they are something that they should be using and applying whenever they're doing any programming. So that's a little bit kind of from me. I haven't really got too much more that I was planning on going through today. Just a little bit of an intro, and I figured there may be some technical issues and things like that to resolve. I'm more than happy to stick around for a little bit longer if anyone's got any questions, or if anyone wants to ask anything now, or if there's something they're not too sure about. And obviously I'll do another one of these next week, and then I'll look at going through the other aspects of 2.1, like the different search and sort algorithms and that sort of thing. So yes, so thank you for attending and listening, and if you have got any questions, please feel free to just ask.
Yeah, thank you, Martin. Hello, sorry. Thank you, Martin. That was fantastic. I mean, I don't really have any questions really, but it was really nice to see how you use Prim in a lesson. So I've seen it about, but I've never really actually seen it, and that was really useful. So yeah, I really appreciate that.
It is something I would recommend. I think I've found it's helped. I mean, this is kind of my 4th or 5th kind of version of it, and trying different ways of doing it. And I kind of got to a point where I think this does actually work, and it helps them. And I think that's probably one of the, because it's something that is fairly recent, and I don't think it's really anything new. I think even before I was using Prim, I was using Prim, if you get what I mean. I was using elements of it. I'd give them some code, they'd look at it, they'd look at understanding it, but I wouldn't necessarily have this structure. And I think that structure really helps, and it's really helped get girls on board with it as well. I think I don't know what your kind of take up with computing is with girls, but since we've been using this, we've gone up to like 40, nearly 50% girls in a lot of our classes.
So you introduced it at the Key Stage 3 sort of level?
Yes. We start. So we do programming in Year 8, some Python there. We use Prim there as well, and the girls just seem to find it a lot more easy to follow, and they seem to be a lot more engaged with it since we've started to use it. And then, like I said, that I don't know whether there was something else. I mean, we do various code clubs and things for girls as well, like the cyber first girls competition, that sort of thing, and that we kind of join the two at the same time. But I think definitely that using the Prim is something the girls tend to find a lot easier to follow, because there's that structure that they quite like normally.
Yeah. The abstraction is an area that I always find difficult for kids to grasp. It's because usually a lot of the examples, you see a map or London Underground sort of, and so I don't really tend to look at any other examples, but that was really cool. Your abstraction method. Could you go through how do you use, you may have those words in a grid. How do you do that in a lesson?
It all depends on how I fancy doing it, really. So one way that I do, I've just set up a game of Pictionary, and just got the kids into groups. If it's a small class, then they just play Pictionary amongst themselves, and I just do it like a scoring thing. And so they just take it turns, team by team, and they choose it, or they get a word and they have to describe it and or draw it and that sort of thing. Or you could just get them into pairs, and they have to see how many they can get right, and they kind of compete against each other in their pairs. And so one will take some time to do some drawing and or some describing, and see how many they can get the other person to guess correctly. And then the other person can then do the same sort of thing, and then we'll see whoever gets the most marks clearly did the best job of describing or drawing the picture. So it's just something along those lines. Tends to work quite nicely. And like I said, the element I've used all the way up to my A-level class, and they all love it, and it's just a little bit of fun, really.
Yeah, no, it's interesting. I've never thought of doing it that way. Because basically I just sort of teach them to be able to answer in the exam, which isn't the best way to do it. But it's good. It's good to see how you can make it a bit more fun and interesting.
No, I think it's definitely what we're trying to do, isn't it? You want them to enjoy doing the subject, and if they're just learning things, sometimes there's things you do just have to learn for the exam. But if you can make it a little bit of fun at the same time, then obviously they hopefully enjoy it. So
no, that's really really useful, really useful.
No problem. I'm glad you found so. Has anyone else got any questions or anything? or anything they'd like to add? Any ideas that they use that they think are useful?
Oh, hi Martin, can you hear me?
Yes, I can, yeah.
Oh, hi Martin, my name's Jessie. I just yeah, thank you so much for that. It's really interesting to see how you do things, and particularly the PRIM model, something that I've thought about using. But I also wanted to find out about whether you've tried peer programming before and if you find that useful.
I haven't used it that much, mainly because it's my setup in my room is quite difficult, and we're very much about kind of evidence of things, and I find the evidencing of peer work a lot more difficult to get working properly. And if the evidence isn't there, then we tend to get a lot of stick for it. So it's not something I tend to do too much. But I do look at there's something we try and promote is kind of helping people out and so on. And something we've also developed is something that I've kind of called a culture of error, where they have. Show you. I've created some posters that we've got and that they go through, and we look at them, thinking about the errors, but looking at how they can go about solving it, especially using things like C3 before me. But alongside that, they have an error log that they have to keep track of and use as they go through. And obviously using peers work as they go through is something that we kind of do, but I don't really do too much about kind of peer programming as such. Is it something that you do use and find useful?
It's something I've tried, but obviously it's quite difficult, obviously depending on the room setup.
Yeah.
And also and also the sort of disruption that happens, sort of moving around and things like that. It kind of get a bit distracted. But I have heard that it does sort of, I've heard the evidence is that it can be helpful. So I just wanted to find out other people's opinion, really.
Yeah. No, I don't know if anyone else uses it well. I do know that one of my other trust schools, they use kind of a mock peer program, if you like. They give all their students a rubber duck at the start of the year, and they have to talk through any problems with the rubber duck, and that tends to help them out a little bit. So
I've heard that one as well, actually. Yeah.
And apparently that works quite well, but I don't know if anyone on here has got a good experience of using peer programming at all.
I use peer programming. My name's Mary.
Hi.
Hello there.
Mary.
Hi. I have used peer programming. I did it when I did the conversion course from IT to computing. So I did that as my project. It was really interesting because I teach in a boys' school.
Okay.
So being a female teacher in a boys' school teaching computer science, it was interesting. But I've got them on my side now, which is great. But no, it was interesting to do it because I did it in my year 8 group. My school, we don't really do group work or anything like that. So I got permission to do it. Yes, it worked, but again, it's really difficult to see how the groups work together. Don't know if I would do it again for GCSE because again we start from year 9, so in year 8 we do a lot of programming, which we love, and we use Visual Basic in our school. So yeah, I liked it, and I will use it for students who are struggling, and I will sit them with the next higher type of student. But yeah, I wouldn't recommend using it all the time.
Okay, that's good to hear.
Thanks, Mary. That was interesting. Thank you.
Brilliant. Has anyone else got anything they would like to add or anything they'd like to ask at all?
One thing I'd like to. Sorry, this is Neil. One thing I'd like to add. The Flogorithm program. What are the limitations of Flogorithm? Like, can you go as far as reading, writing text files at that kind of level?
No, it can't go quite that far. If I'll just grab it again, if I can find where I put it. So these are kind of the instructions that you've got. So it's just really goes as far as things like looping and that sort of thing. You can create sub functions in there that you can then use as well, and you can comment it but that's pretty much as far as it goes. It does have an extra tool which you might like, you might not like. I don't tend to use it, but if you've got a program, and I've got to remember where you find it as well, you can go to the source code viewer, and you can change it into different languages. So you can put it into Python, things like that, which see, it helps if they've got some students struggling to find links between them. But with some students, you find that when they're trying to write Python, they might try and use Flowgrim and then just convert it into it as well, which obviously then doesn't particularly help. But it does help them see the difference between certain tasks in different languages and why you might choose to use one language over another. So
just so I heard that right. So
yeah.
So you can sort of convert that to like a Python language.
Yeah. So under the tools section, so there's a source code viewer, and so I don't know if you can see this window that's just appeared. Possibly not. Bear with me, because it's a separate window that comes up. So you get this window.
Okay.
And so within there's a drop down box, and it gives you all sorts of different languages that you can use. So someone said that they've got Visual Basic, so you can see what it might look like in various different languages. And I always like to show it in something like C and things like that, so they can see why they'd use one language over another and why we teach in a particular language and that sort of thing. So.
So technically, you can almost sort of copy it and put it into your own sort of, say, Python editor.
Yeah, so it's all valid code. So if I do put this into Python, you'll see that that's, hopefully, if you're familiar with Python, you'll see that that's a perfectly suitable code that will work in Python, and they just have to copy and paste it. There may be certain bits in there that won't necessarily work, and they just have to edit it slightly, and that's where you'll be able to kind of see the issues and see that they've just copied it from Flowgrim rather than writing it. But I tend not to use that feature too much, because some of the lazy ones will try and take advantage of it, but it is an extra tool that you do have on there that you can talk them through if you think it's suitable.
Yeah, that's good.
Brilliant. Anything else from anyone? So, if that's the case, I will end this session now, and I will put together another one. I'll advertise the next one for next week. I might not do Monday as it's a bank holiday, although all the days do seem to be the same at the moment. I don't know how it's feeling for anyone else there, but I'll put a session link on the Facebook group again, and hopefully you can join in next time as well.
Brilliant. Thank you very much, Martin.
No problem.
Thank you, Martin. Awesome.
Thank you. Thank you.
Brilliant. No problem.
Thank you.